Hello and welcome to another episode of the Measurement Lab. I am your host, Elijah Carey, and today we're going to be talking about gRPC and how it can be used in test and measurement systems for the sake of interfacing with other languages and other IP. And I'm joined by one of the architects of the technology we use to interface with gRPC, Chris Cifra. Chris, before we get into gRPC, who are you, what's your role, and when did you first join NI?
All right. Yeah, I'm Chris Cifra. I work today in our what we call the platform organization, which essentially is responsible for all of the test and measurement software that we ship. So everything from LabVIEW, Test Stand, Instrument Studio, FlexLogger, all of our products that, essentially if it's on the desktop, it's in the platform org. And I am basically working to see how we can advance our software, what technologies we should leverage, and trying to understand what we should really be doing to move our platform forward to make it more valuable to all of our users out there.
And if I'm correct, your title, you're a distinguished engineer. Is that correct?
That is correct. I'm a distinguished engineer. I started at NI in 1996, working on a product called HiQ, which maybe some of you may remember. I doubt it, though. So coming up on 28 years here now at NI. So, yeah.
So what would be your first LabVIEW version that you were working on?
Well, since I was in HiQ and stuff like that, basically LabVIEW 6, I would say, is where I really got involved working on LabVIEW related activities here at NI. Back then we had CVI and other products that I was more involved with.
And importantly, as a distinguished engineer, hard for me to say that word, I think it's important to emphasize that you're really in a position where you're looking at cutting edge new technologies and technological advancements and figuring out how to incorporate them into our platform and when and how and if they might be relevant for our users. And so in that vein, I think gRPC was one that you and I first interacted with a few years ago. Let's start by not assuming people know what gRPC is. Can you give us a quick crash course? What is gRPC and why should I care about it?
Sure. So you can think of gRPC essentially as an RPC framework, so remote procedure call, right? So basically, if you want to talk to things outside of your application, so you could think, in the old days, we had things where you would basically talk between processes running on a system, and then that's evolved to being more like, okay, I want to talk to computers across the network, and there's a variety of ways to do that. Things have evolved since 1996 when I started playing with things like this. Microsoft. I don't know if you were familiar with something like called COM or
sure. Test Stand was written on it.
Right. And that's for communicating between things within process, and then they have distributed COM, which was a way of doing that across the network. The problem with things like COM, distributed COM, is that they are proprietary to a particular platform or something like that, right? And then so as the internet evolved, things like REST APIs and HTTP APIs and things that you use in the browser became very popular, and that's kind of the dominant way things are done today. But when we look at test and measurement products and things like that, there's kind of a different need than what you would typically see with a REST API or ways a browser application would talk to its backend server. We need higher performance. We need secure communication. We need streaming APIs and things like that. So gRPC actually is an evolution. You can think of it as on top of what you see HTTP APIs or REST APIs today. It takes advantage of the more modern capabilities of the HTTP protocol to enable high performance binary data communication between entities. And so it's a very network friendly API because it's built on the same core fundamentals of HTTP that everything is built on. The entire internet, essentially, with all the web browsers and backend servers, they all communicate over HTTP. And so gRPC gives us that plus high performance.
Well, and importantly too, a lot of the requirements you just spoke to, as far as like the distributed communication, those are things that have emerged as core needs for all sorts of technical applications outside of test and measurement. So where did this first get its start, and where does it come from? What's its background?
of gRPC itself. So
Yeah.
essentially, it started out as an internal project at Google. So Google, um, people will think that gRPC stands for Google RPC, and they will deny that. Now that it's an open standard, they didn't want it to be associated with them. But it started out what they used internally to communicate between all of their backend services. So the running the Google search engines, all the tools involved as far as making the Google web browser, API, what it was for doing Google searches, all the backend systems that are involved in that, all the communication that happened between those, they wanted a higher performance solution than what was typically available. And so they invented gRPC. But again, like I said, they wanted it to be something that was very compatible with the rest of the internet. So that's why they built it on top of HTTP instead of basically making it their own kind of proprietary standard. And so it comes out of that need to basically have a competitive advantage over everybody else for is basically is how good your services can communicate on the back end when you're building a large distributed system, right? And the Google back end for their search is one of the biggest things out there. Um,
Basically, you have the world's, largest vendor of massive online search, at least at the time,
yeah,
needing more efficient ways to have communication, and they led to this protocol. So,
right.
can you compare it? When I think about communicating between multiple systems, I think about protocols like MQTT, obviously, RESTful APIs, et cetera. Can you help us understand how it's different and like why those weren't sufficient for what Google or anyone who
Yeah,
uses gRPC needs?
absolutely. And they're like I would say RPC frameworks today or communication protocols, everyone wants to make one, right? It's like it's kind of a fun thing to do. And so there's a ton of them out there, and you can always look around. You can always find one that has something that is a little different and maybe a little bit better. One of the key things with gRPC is we think it's a really good balance between all the different things. And you have things like MQTT or Kafka or things like that, which are message buses, message brokers, where they're essentially sending out like, signals to everybody else saying, hey, this happened, or here's some information. And like, I'm not going to pay attention to you processing it. I don't even know who you are as a consumer. So producers and consumers are very decoupled, right? And uh, they're just producers send information, consumers consume it if it's interesting to them, right? And so it's a more decoupled solution. Um, and then things like RESTful APIs, those are very designed for uh, basically the communication over unreliable networks or communication between a browser and a server where the client comes and goes kind of at the user's like whim. Like there's not a like it's so it's a very it's not a strong connection. And with gRPC, it's more of like, again, an RPC framework, which is more like a function call style of communication where the client sends a message to the server, the server sends back its response. It's a one-to-one communication, and you have a very kind of permanent connection for as long as you need it. And that is what enables this high performance communication. So we found that for things in test and measurement, that style of communication is what typically we need most often. Now, not every case will call for that, but dominantly what we see in our style of applications is that's kind of client to server, basically remote function call, right? I want to talk to a piece of hardware. I want to get data from it. I want to send it configuration information and get a response back that it was successful, right? And so that is where I think gRPC really works well for us.
Well, and I typically think of the data that a test system is producing as being somewhat unique in terms of the volume of data and the nature of that data, at
Right.
least relative to like general purpose software and even
That's right.
enterprise software applications. And so how does that intersect with gRPC? Is it well suited for the type of data you typically see in a test measurement
Yeah.
system?
Like, when I was in school, like, you know, converting from floating point numbers or other binary formats to text was considered a lossy operation, right? You don't take an arbitrary floating point number, give it the text, and get it back at that same floating point number. There's a lot of challenges in doing that correctly. And so if you look at things like a REST API or JSON, if everyone's familiar with JSON, essentially it's a structured way of sending information, which are used by REST APIs or HTTP APIs. So you basically encode everything as text and you send that along.
Yeah, you serialize it, right? And you
You
have to have
serialize
a
it to
serializer.
text, right?
Yeah.
And so what they call the wire format, right, is text. It's a big text stream. gRPC, one, that's slow, right? Because serializing from binary to text back to binary takes time. It's also bigger. Most of when you take a number and you convert it to text, the number of bytes becomes bigger, so it becomes slower over the network. So all those things are slow. gRPC takes a different approach, which basically says we're going to define a standard binary protocol for moving data. And so you define what they call messages, which are a structure. Think of it as a cluster in LabVIEW that contains the information, and then it's serialized in basically the same format that you have in memory for those same data types. So, floating point numbers and, scalars and strings are all exactly the way you would have them in memory. And so there's no loss of information, and there's no encoding, decoding that has to happen. And so it's well suited, again, if you have large arrays of doubles, it's essentially a copy into the buffer of the network card to get it over the network to the other side. And so there's not a lot of basically encoding, decoding that has to happen.
Okay, so let's double click on the mechanics of it, and we'll paste some references in the description. But if I want to get started with gRPC, great. I recognize I got a bunch of data. I don't want to take the performance hit of serialization. What do I do? How do I begin to use this protocol?
So one of the really nice things with gRPC is that it is what we call strongly typed, basically protocol. And so there's a file format called a .protobuf proto file, where you define the messages you want to send across. So you can say, okay, I want to create a message, and it has an array of doubles that are my waveform values, and it has another double that is like the start time, and then you have some string information about it, some attributes or something. You define that message however you want it to be, and then you basically run this compiler on it to generate a language wrapper for you. And so gRPC supports just about every language you can think of. The community and Google and companies like Microsoft and Amazon all use protobuf, and so they all contribute to this support for, once you define this standard format, then we can create a language, basically a nice API in whatever language you want to use to serialize that data. And so that's where you start. You start with protobuf. You define your messages, and then you can also define your API that says, okay, here are the functions that I want to be able to use. And then something will generate the code for you then to implement that contract that you defined.
Okay, and of course, we can post links to tutorials on how to get started and use the IP.
Right.
But effectively, what you've done is made it so that protobuf file, which is a language OS agnostic description of the messages. Correct me if I'm wrong here.
Yep.
That you made the IP so that LabVIEW can consume that protobuf file and then know how to interface with anybody else that then consumes that same protobuf file.
Yeah, and exactly. So like I said, it's a community-driven activity to take a protobuf and convert it to different languages. And so different language owners, so like Microsoft owns .NET essentially, and so they've built the protobuf and the gRPC support for .NET. Google, owns Go, for example, and they've built a Go interface to that, and then Python and other things happen, and the community takes on a whole bunch of other different languages. And us, as the owners of essentially LabVIEW, did the work to integrate this, essentially a compiler, to basically parse that description in a proto file and generate LabVIEW code to do the same thing. And because it's a standard across the network, the client, both sides don't have to be in the same language or anything. There's a well-defined standard for how things communicate, and so you can write a LabVIEW program now with our gRPC support and have it talk to something written in Go or .NET, and it works, the same. You don't have to worry about the other side. And that is part of it's really what makes it powerful is that now you can basically decouple your different
Right.
sides of the thing and use the language and the tools that make the most sense for you.
Well, and I think it's interesting. It's an interesting example of how the nature of our customers' systems is evolving and changing in this modern era. I think, you mentioned Go, right? That was one of the driving forces behind it, in the sense that we had a customer that specifically wanted to interface with a system in Golang. But I mean, let's use that to then kind of talk a little bit about how we see the architecture and topologies of test software evolving in this modern era. Right? This is being driven obviously because you need communication between multiple entities, both because of your work on gRPC and just your purview as a distinguished engineer looking to the future of test software. Can you
Right.
comment on how you're seeing these technologies, well, really the test software architectures and requirements evolving and driving this type of need?
Yeah, and I think test software kind of follows the greater software industry as a whole, and kind of we pick and choose the pieces that make the most sense for what we need for test and measurement software. And so if you look at the software industry as a whole, right, you see distributed systems, where systems are running on the cloud and on the edge. And you're building things using a service kind of based architecture where you're taking things, you're no longer building monolithic applications, you're structuring things into more services that you can maintain independently. And then the communication between all those things is essentially the network, right? The network essentially has become our new de facto way of communication, and the network protocols are what are binding now between the different entities. It's not like, oh, I'm using C and here I'm using the standard calling convention for calling into a DLL, or I have these other calling conventions, and how that all works. Nowadays, it's all the network. Right, everything is structured around the network and communication between services, and things like containerization or different distribution models are all basically structured around that same approach. And so we see that kind of moving to the test software as well, where you now have distributed systems where you may have n different test stations all running parts of your test system on next to the hardware, doing the acquisition, doing some initial analysis, but then feeding those results back to a central place and having that kind of coordination happen. And so as we try and simplify our test software, the hardware that we're using, we have to move the compute somewhere else. And so following that trend of building things into services and looking for good distribution models like containerization and stuff like that, makes things like gRPC and network communication very important to how we structure our software.
I want to probe on why that evolution is happening. You described it as, you're taking the compute away from the instrumentation or the hardware at the edge and centralizing it. And, to me that sounds cool from a technology perspective. But why? Why are people motivated to do that? What's driving that topology and test?
um, Part of it is, I mean, there's a lot of factors. There's certainly factors like cost, and maintenance and things like that. If you have a lot of uh, nodes at the edge, is the software industry will call it, but basically test stations or individual PXI chassis, those, if you have a lot of those, making them simple makes the costs go down and makes the maintenance go down, right? And I think maintenance is actually one of the most important things, which is that stack that's on there isn't specific to the test you're running today or the test you're running tomorrow. It's more generic, right? So that it's a lot easier to maintain that. And then you move the specific things to somewhere more centralized, so it's easier to maintain your stack. Having to distribute it to 500 test stations. You can say, well, those 500 test stations are generic. My central set of software that's managing the tests is what's unique to today's test or the I'm working on today, or this version of it. And so it's a lot easier to maintain your systems and to ensure that you have consistency as well. And so by following these standards, which you think about like a cloud system where you might have to scale to 20 million users, and you have to have the same software across 10,000 nodes. Well, you're not going to do that by running an installer on 10,000 nodes, right? They have
True.
different approaches. And so we see that same advantage, maybe to a smaller degree, but those same kinds of things that are happening in that industry are what we can bring to test software to basically simplify this maintenance and development.
What you're describing to me almost sounds like the way I kind of treat my personal laptop. It's like, yeah, I have my machine that I work on daily, but if you took it away from me and gave me a new one, it's almost disposable in the sense that
Right.
I can then log in and see all my same documents on any machine. And you're describing that in a way, the instrumentation at the edge becomes equally transactional, where I can just, if that software is centralized, I can replace it with a new system and be operational less time.
Right. Right. Exactly.
But
Yes.
that makes sense. But like, I guess it still assumes there's a lot of bespoke design of the instrumentation in that hardware. It's not like every hardware set is truly interchangeable. Your point is
Right.
just the software becomes
This software, right? And we're not there yet, right? That's kind of a future world that we're kind of looking towards. There's like we have, like you said, we have different performance needs than the generalized software industry. We have different latency needs and things like that. So we look to the software industry as like, okay, this is where a lot of effort is going, right? This is if you look at the millions of software engineers working on things versus a much smaller pool working on test software. Well, what can we take advantage of, and what makes the most sense for us? And so we're starting to see those things. We're trying to figure out how we can bring them into our world to do to help us, with these kinds of things like test management and things like that. There's a bunch of other advantages too, but starting to try to understand like what's most valuable for us, and what can we bring to the table for our customers.
I know too in especially in settings where you don't necessarily know exactly what you're looking for. So, the most obvious example that would be some sort of validation lab.
Right.
Now it becomes really important you get as much data as quickly as you possibly can. And then, maybe you're training a model or developing a neural network. And I think that
Agree.
also speaks to the need for these distributed systems with centralized intelligence, which I
Right.
believe is a big part of what you're working on these days, right, Chris?
Yeah, that's right. Yeah, and so like if you saw our keynote at NI Connect this past April, we showed basically the beginnings of that vision, right? Where we're trying to figure out when we call it intelligent tests, right? Which us really means a couple of things. It's really just trying to improve the workflow, bringing intelligence to the table to help you improve your world. That may include AI, and there's a lot of places where we're seeing AI and large language models really being a huge benefit to that. But it's also generalized workflow and improvements, and so we're trying to look at all of that and find the best tools for the job. And obviously today AI is a huge trend, and we want to make sure we understand it and we can bring it to the table where appropriate.
Okay. Well, and it makes sense. And it seems understandable that gRPC would be an enabling technology in a setting where you've got a bunch of data you've got to
Right.
aggregate. I do um, want you to help contextualize gRPC because I know from my interactions with customers, there's an alphabet soup of other ways of communicating. We mentioned a few
That's right.
earlier. There's OPC UA and Ethernet, or yeah, Ethernet IP, EtherCAT, and
Right.
Profinet,
Right.
and so many others. Are there are there other protocols or technologies that you put in this same uh, bucket of foundational tools for these types of uh, distributed test systems? Other things that anyone watching this video should also evaluate as a way to connect and build these complex distributed topologies?
Yeah, I mean, and there's really there's essentially three big buckets where we see it as your typical REST application or using HTTP API. So if you're building a web front end, you're trying to build some UI that can talk to your distributed system, you should really be looking at REST for those kinds of things. And if you have this, the second one is what we basically this service to service communication, or you know and when we have services like today, we have gRPC device for talking to NI devices across the network, right? Using gRPC, And then if you want to do, like, if you're writing a couple of LabVIEW services, using gRPC to talk between those makes it easy for you to move them around on the network, right? They can be next to each other on the same machine one day, and you can be like, okay, this one wants to use a GPU or something. I want to put it over here. It's easy to move things around, and you don't have to change any of your code. Right? You just change the address that you're talking to. And so that's one of the nice things about this, is that it's easy to move these things around. And as we standardize that protocol, it becomes very easy to use. And again, high speed measurement data communication is where we see gRPC being a great fit. And then things like message buses, right, is kind of what you mentioned for MQTT and stuff like that. That's kind of this third bucket where if you're interested in this kind of publish and subscribe model, where you have something just producing information that someone might be interested in, and then you have consumers that wanted to subscribe to the things that are interesting to them, something like MQTT is very popular for that kind of thing. And so you think about that first, of like, what is my style of communication, and then look at the technologies. And so
Gotcha. And it may be a mix of various communications.
Yeah.
It's something you said I want to go back to, because I think we've, at least in this discussion, I've anchored to a mental model of compute running on different physical targets. But you mentioned containerization. And of course, that's a technology we're seeing more and more interest in, for the sake of, scaling compute and capacity. But containerization does not necessarily imply multiple physical execution, like pieces of hardware. And so is the implication that gRPC is potentially a way to say, I've got my workers, they're containerized, they are talking to each other in gRPC, whether they're on different targets or not. Is that a fair? Okay. And then you can move those, and it doesn't matter.
And it doesn't matter, right? And if you look at containers or things like that, the easiest way to talk between containers is over the network, right? That's how the technology was designed. That's what everybody else is doing. So when you try not to do that, you're kind of like fighting against what all the best practices are, what people make sure is really great. And that's another reason to start like saying, okay, I'm going to talk to my hardware, or I'm going to talk to other parts of my system all through the network, even if it might be on the same system, right? But the network on the same system works great too. It's actually a very low latency communication path, right? A lot of OS vendors work really hard to make sure that the communication for the network on the local system is highly optimized, because it's a very common thing to do.
So for LabVIEW programmers who would be familiar with, like, producer, consumer, queued message handler, and I've got my separate loops in my block diagram. Now, conceptually, those while loops become containers, and instead of having a queue to talk to each other, I'm using gRPC. Is that fair?
That's right. Absolutely. Yeah. Yeah. And then you can, separate those out. You can use, if you have to rev one and not the other, you don't have to keep them the same sync and same LabVIEW version or anything like that. They can drift, right? And it's perfectly fine. And so it helps you. And if you have different teams working out different aspects of it, it all works very seamlessly. And so it's a great way to structure your applications.
I love it. It's very insightful, Chris, and I appreciate you taking the time to join us. I know you're looking at a lot of other technologies in the future of our software platform, so I'm sure we'll have you back again. We'll also be sure to post some links to how you can get your hands started with the gRPC work that Chris has helped to create, and some tutorials on how to use it. But we'll leave it there for now. Chris, thank you so much for your time and for joining us. As always, like and subscribe if you want to get updates on this and future topics.
All right. Well, thank you.